So I'm Dr. Lutz Mary, Associate Professor in the Department of Computer Science and Engineering. I'm going to take the topic Virtualization Structure for the subject Cloud Computing. So what is virtualization? So hypervisor provides hypercalls for the guest OSs and application. A hypervisor can assume a microkernel architecture, or it can assume as a monolithic hypervisor. Microkernel hypervisor includes only the basic and unchanging functions. Device driver and other changeable components are outside the hypervisor. So we'll see a Xen architecture to understand more about hypervisor virtualization architecture. So VRLM, virtual machine monitor, which allows user to dynamically instantiate an operating system. Host operating system, which are like Linux and open source and Windows. So multiple operating system can run simultaneously and perform different tasks. Completely software based and requires no special hardware support. Xen architecture, it supports unmodified application binaries. It implements all mechanisms, leaving the policy to be handled by domain 0. Core components of a Xen system are the hypervisor, kernel and applications. Not all guest OSs are created equal, and one in particular controls the other guest OS, which has the control ability, which is called as domain 0, and others are called domain 2. So domain 0 is a privileged guest operating system which is first loaded and Xen boots without any file system driver. So use para virtualization to provide high performance and good resource isolation. So guest operating system has to be modified, so it will run on the top of the host machine. So guest operating system has to be modified to run on a virtual machine monitor. Specifically, the guest OS can no longer execute in ring 0 because the ring is now occupied by the virtual machine monitor. The guest OS has to be modified to run outside of ring 0. So we'll see diagrammatically how the Xen architecture will look like. We'll be having the hardware devices. Above that you can have the Xen hypervisor, then domain 0. So domain 0 will have the applications. This control IO domain 0. The other will be called as domain use. So Xeno Linux. So guest domain will be there. So Xeno Linux Windows. Xen architecture will look like this. So virtual machine host server, virtual machine monitor management application, virtual machine VM application will be having internal and external. Then the agent will be there. Then the hypervisor hardware hypervisor. Above that you can have the virtual machine monitor. So you can have the virtual path between the virtual driver and the physical driver to all the virtual machines. Virtual machine host server is connected to all the virtual machines. So we can have the para virtualized OS. It may be Linux, NetWare or MS operating system, whatever may be the operating system. Diversity of the operating system will be used. Cyber platform devices, there will be disk, LAN, USB drives, and the cards will be there. Then memory and CPU, it can support 86, 64 and AMD Intel devices can be supported. So virtual driver and the physical driver both will composites are comprised of IO system. So domain 0 is assigned to access hardware directly and manage the devices. So one of the responsibilities of domain 0 is to allocate and map hardware resources to the guest domains. Domain 0 behaving as a virtual machine monitor, it allows user to create, copy, save, modify, read, share, migrate and roll back. So if domain 0 is compromised, the hacker can control the entire 0. So for domain 0 security is very important. So you have to improve the security. Binary translation with full virtualization. So far we have seen with para virtualization. So how the binary translation takes place with full virtualization we'll see. Depending on the implementation technologies, the hardware virtualization may be either full virtualization or host based virtualization. Full virtualization does not need to modify the host OS. It relies on binary translation to trap and to virtualize the execution of certain sensitive non-virtualized instruction. So binary translation, why we are doing this, including Java and everything will be transformed into bytecode, because it cannot able to track, and the security will be more. Binary translation with full virtualization, it scans the instruction stream and identifies the privileged instruction. When these instructions are identified, they will be trapped by the virtual machine monitor, then which emulates the behavior of the instruction. This method used in the emulation is called binary translation. It is shown in the diagram. Host-based virtualization, dedicated application may run on the virtual machine. Certainly, some other applications can also run with the host OS directly. Host-based architecture has flexibility. Para-virtualization, you can have the hardware, VMM, then application, para-virtualized guest OS. So, traditional x66 processor offer 4 instruction, ring 0 to ring 3. The lower ring number, higher the privilege. So, the OS is responsible for managing the hardware and the privileged instruction to execute rings at the user level. So, we'll be having the host one, virtualization layer, para-virtualized guest or hyper calls to the virtualization layer replace non-virtualized OS instruction. So, how the compiler will support? Guest OS running at ring 1 instead of ring 0. The guest OS may not be able to execute some privileged and sensitive instruction. The privileged instructions are implemented by the hypercalls to the hypervisor. After replacing all the hypercalls, the modified guest OS emulates the behavior